Good morning, class. So at this point we were busy with functions. The lesson before. Just go pick that up, please, Michael. Go pick it up. It's ugly what you just did now, no? Okay, so at this point we're busy with functions. And the one that we need to do before we start, or before your exam, is this one dealing with exponential functions. Not so? So in this exponential function, I was going to post it over here. This is number 3 now. No, I do. Where am I now? Okay, so I'm just going to throw away a Cartesian plane quickly. I'm going to pause the video quickly, no? Can you just check something? Alright, sorted. Here we go. So in 7.5, the number 3, they ask you to draw. They ask you to draw the exponential function, not so? And the exponential function they asked you to draw was 2 to the x, 3 to the x, and 4 to the x. Okay? So I'm just going to change this a bit, because everything happens above the line. So we just make that a bit bigger above the line. So you're going to go to minus 2, but you're going to go to, say, 14 on your x. Oops, that wasn't what I wanted to do. It is on your y, negative 2 and 14. Okay. Okay. So when you drew it, you guys did this by using a table, not so? No? Did you guys do this graph by using a table? No, you x-intercept with y equal to 0, y-intercept. Okay. So what you should have noted at this point was that the first graph, which was y is equal to 2 to the x, you had to first draw the table to establish the characteristics of these graphs. It's the first thing we needed to do. Okay. So have you dealt with this graph before? No. So that should have given you x and y. Minus 2, minus 1, 0, 1, 2, and 3. If I put minus 2 in here, I get a quarter. Minus 1 gets you half. 1, 2, 4, and 8. Can you see that people? So at minus 2, you got a quarter. It's approximately there. Minus, no, that's minus 4. Minus 2 and a quarter is approximately there. Minus 4. No, minus 1 gives you half. 0 gives you 1. 1 gives you 2. 2 gives you 4. 3 gives you 8. 4 gives you 16 and so on. So if we connect these dots here, that's what that graph is going to look like. Can you see that, people? It's actually going to go steeper at 4 because a 4 corresponds to 16. Can you see a 4? We give you 16. And 16 not even on this graph, so it will never cross that even. If I said minus 3, would have given you 1 over 8, 1 over 16, 1 over 32 and so on. I'll come close and close to the x-axis, but I'll never touch it. Can you see that, people? And this is also known as what? This y is equal to 0 line with the x-axis. It's an asymptote. So this graph has a vertical, an horizontal asymptote. Can you see that, people? It only has one asymptote. Does it have a line of symmetry? No. Okay. If you look at the other graph, which was y equals 3 to the x, and you do the same thing. You go minus 1, you get the third. Minus 2, you get 1 over 9, which is less than that, and so on. 0 gives you 1. 1 gives us 3. 2 gives us 9. 3 gives us 27, which is way above that. Not so. Again, take the smooth curve. Outer ruler, we're drawing this graph. And again, the graph is going to come close here, but does not touch the axis. Okay, it looks like it's touching it, but it doesn't. The idea wasn't for it to touch. Graph comes close, but never touches this axis here. As you know that, because of the situation we find ourselves in, it looks like it's touching, but it shouldn't. Okay. This is y is equal to 2 to the x. And the other one was y is equal to 4 to the x. Not so. Y is equal to 4 to the x. So if you put negative 1, I get a quarter. It's even lower than that. 0 gives you 1. 1 gives us 4. 2 gives us 16. No? So that's already off the graph. Again, your exponential growth there. That graph is going to come through like that. So of course come down here. And again, up all the way down but never touches. Okay. So as, if it's in the form of y is equal to a raised to the x, as a is greater than 1, you see that the graph is always doing that. Okay, see, an increasing function. Can you see that? The graph is increasing. Why? Because as x increases, the value of y increases. What's the domain of this graph? Domain of all these graphs are the same, the range is all the same. So what is the domain of this graph? Negative infinity, positive infinity. X an element of all real numbers. What's my range of these three graphs here? Does this graph exist at negative infinity on your y? No. Where does it start existing at? 0 onwards. Can you see that, people? So y is greater than 0. Can it be equal to 0? No. Why? Because at y is equal to 0, there is an asymptote to the graph. Yes, Michael?
So sorry to disturb you.
No problem.
Is it possible that the domain could be x is an element of all numbers?
X is an element of all real numbers. What did you say? All the numbers?
Whole numbers.
Whole numbers. You see, if it's whole numbers is from 0 to infinity, but considering only the like numbers 1, 2, 3, 4, 5. So if that is the case, then you must look at the graph that has this. If that is the case, or are you, no? And only dots there, not a line, then yes, this would be x is n is an element of, you started by 1, so it's natural numbers. If I had started at 0, it would have been x is an element of whole numbers. You would gone all the way to negative infinity, but only considering the negative numbers, the whole numbers itself, negative and positive. Only considering the integers, and it's dots only by the integers, then x should have been an element of integers. But because it's a solid line here, that is why x is an element of all the real numbers that exist. And it's true. If you look at let's say 1.5 here for argument's sake on this black graph here, which is y is equal to 2 to the x. Go to 2 to the x 1.5. Replacing x with 1.5. You'll see it will give you approximately that value. There's 2 to the exponent. 2 to the exponent 1.5. It gives us 2,87. Okay, now again my graph is not drawn to scale. Okay. But if I draw this to scale, you would have seen that this graph comes somewhere here. Comes in here. You understand? If I had gone with 2.5, you will see that value will fall in line with that. You understand? So all these values in between is also part of that graph. But why do I draw the graph with those values is? Because there's nice rational values to it. That's the reason why we choose it. That's the reason why I chose those values. Okay. Anything else? So what would happen? What other questions did I ask you with regards to that graph? What is positive? Let's read that is exercise 7.5. Number 3. What page is this? I didn't put the page number in here. 150. So let's go to the questions quickly. Spoke about the hyperbola. We're on page 151. The function defined by the equation h of x equal to k to the x where k is greater than 0 and k is not equal to 1 is called the exponential function. Draw the graph. We draw those 3 graphs now on the same system of axes. The first question says, each graph have drawn pass through a single common point. What is this point? All these graphs are going to the same point. And what point is these graphs going through? Sorry? 0 and 1. Okay. They ask you for the point, so the point is 0 and 1. Okay. The next question is C. Choose a correct option. In each case, the graph drawn as x increases, the value of y increases. So that is what makes it it makes it an increasing function. No? Is that correct? You would understand? Then it says, choose a correct option. Each of the graphs drawn is of the form h of x equal to k to the x where k is greater than 0. The larger the base, which is k, remember the standard form of this equation is y is equal to k to the x. That's the standard form. Okay? The steeper or less steep the graph is. So as this increased, what did you notice? From 2 to 3, it became steeper. From 3 to 4, what happens? It became steeper. So as the base increases, the graph becomes steeper and steeper. Okay, so the answer is becomes steeper. E. If the domain of y is an element, if the domain of y is equal to k to the x is a set of real numbers, what is the range? We have spoke about the range. So the range is y is greater than 0. If choose the correct option, all the curves drawn approaches a negative x or y axis, negative or positive x or y axis asymptotically. So this is approaching this is all approaching a negative x axis. And it's approaching which value? Wait. The curve drawn approaches the negative x axis. So the one answer is negative and the other is the x axis. What's the equation of this x axis? What with the equation? If the question is, what is the equation of the asymptote? Y is equal to 0, which is the x axis. Okay. The last question then. Choose the correct option. The graph drawn at it has a horizontal or vertical asymptote? Horizontal asymptote is the answer then. And the equation of the asymptote is? Y is equal to. Yeah, it's a beautiful exercise. I could have put this in the exam. Choose the correct one. No? Yes, easy. What is it for the I've seen it now the first time. Well, I've given you guys an investigation. No? Okay. Huh? I could have given you an investigation on this. So it's a couple of nice questions that they ask. And it's relevant to our study here. Okay. Right, so let's take this off. Let's do number 4. And this is on page 150. It's actually on page 152, but the exercise starts on page 150. Okay. People will be looking at number 4. In number 4 again we got P of x is equal to Q of x and R of x. So let's go. P of x is equal to a half to the x. Again we draw a table. We go minus 2, minus 1, 0, 1, 2, 3, if you could. Okay, so we go minus 3. Minus 3 corresponds with 8. So hang on. We had gone with minus 4. Would have been 16, would have been off. Okay, so it won't go over minus 4 on that side. Minus 3 is of course 8. Now minus 3 is 8. This is minus 2. Yes, what is minus 2? Guys, help me out here. It's like I'm a crazy Brian. Talking to himself. How's Anna feel? Alright. So what do I do? Do I do best? Which is? No? No? Connect the dots here. No? Somebody tell us one thing and then we know the yellow spiel, no? The whole story. Yeah, you're nodding. Nice. So that is P of x. Okay. Then Q of x was a third to the x, not so. So you put minus 1, minus 3, it's 1 over 27. 2i. Minus 2, 1 over 9. And it's going to give you 9. Not so. Minus 1 is 3. 0, 1. 1, third. 2, and 9. And so on and so on. Okay, again, connect the dots. It will never go over that line there. It goes here and then below the line. And this is your graph of U of x. That's all. This point here is actually there. So that's the point of intersection. Okay. Again, people, this is not drawn to scale. Or because of, I can't draw that accurately going through. But it's not crossing there, it's crossing at the 0 and 1. Okay. I'm going to draw this graph on the program. You can also see the effect of this, and then I'll post that and answer questions with regard to that afterwards. Okay. PQR, R of x was 1 over 4 raised to the x. So minus 1 gives you 4. Minus 2 gives us 16, which is again off the graph. 1 and a quarter and so on. So again I draw here, going through there, and there we go. Of course, under the red column. That is your R of x. You all agree with that, people? So what I'm going to do is I'm just going to draw it on the graphing program, and you can see also what it should look like. Okay. Again, it's a smooth curve. It's drawn without a ruler. Okay. No. So insert a function. What's the first graph? It's a half raised to the x, not so? So it's 1.5 raised to the exponent. Alright, so let's do this quickly. So you all got that Desmos program now on your phone? Right, let's take this Mickey Mouse off here. Wait, let's do this. Right, we rather paste it over here. Okay, and here's a graph we said we just drew. Can you see that, people? Yes, sir. Right. So let's answer the questions pertaining these graphs. Okay? First questions first. We drew the graph, right? B, 4B. Why do I have number 3? It's number 4 on page 150. Okay. First question, we've drawn the graph, number B. Each graph you have drawn passes through a common point. What is the point? They're all going through 0 and 1, which is that point there, which is also your y-intercept. Okay. The next one, B, C, choose the correct option. In each of the graphs drawn, as x increases, y, the dependent variable, decreases. What do you notice? It's going down. Okay, the x is your independent variable and y is your dependent on x. So it's your dependent variable in this case. Okay. So this is also known as what? As a decreasing function. Not so? C, a D. Choose the correct option. Each of the graphs drawn for y is equal to k to the x for k is greater than 0 but less than 1. If it's in that form, y is equal to k to the 0, the graph will be a decreasing parabola and a decreasing exponential graph. Okay. The larger the base k, the steeper or less steep the graph will be. Will be, as you can see, this was less steep. Why? Because that's now your negative gradient. Okay, so it's less steep. Okay. E. If the domain of y is equal to k to the x is a set of all real numbers, which is, they ask you for the domain of this graph, it will simply be x is an element of all real numbers. What is the range of this graph? What's the range? The range is all possible y values. So what can we say about this graph? Y must be more than 0. Can it be equal to 0? No. Why? It's an asymptote. Not so. The graph doesn't exist. The graph doesn't cut that y is equal to 0 line. It comes close to, but never crosses. If complete the following statement choosing the correct option. All the curves drawn approaches the negative or positive. It approaches the positive x or y axis, x axis asymptotically. Okay, it's an asymptote. Complete the following statement. Choose the correct option. The graph drawn has a horizontal or vertical asymptote? The horizontal asymptote. And the equation of the asymptote is y is equal to 0. Okay, will you guys understand? So if this question comes in the exam, okay, you can just draw the table. You go -1, 0 and 1, maybe put a 2 there if you like, x and y, or you can put -2 in as well. If you must draw the graph y is equal to x, just complete 1, 0, 2 and 4 and we draw the graph. You understand, people? When you come back after the exam, we will do the last part of this, okay, and then we will draw the graph without the table. And I'll give you that one more. It's not going to affect your exam. If it comes in, you draw the table. That should suffice for the exam. Okay. When you come back, we'll do the last part of this, and we will do determining the equations of graphs. Okay, which is after the exam, and then you will have a break each year, June holiday. When you come back, we're going to write a cycle test again on graphs. Next term. Yeah. No. And you will write on financial maths as well. Okay. Financial. At this point, you should have completed the chapter on financial maths. There will be tests on that as well. Yeah. So get your ducks in a row. Yes. Sorry? As a mom. Di my kind. Listen, come and show you what was tested in last June exam for grade 10. No, let me show you everything. Didn't I send you that paper yet? Yes. But for those of you who haven't seen the paper I've sent to the group, which is probably most of you. Okay, I'm just going to stop the video here.